In this video, we are trying to determine the surface area of this triangle. Let us say the triangle lies in the plane x plus y plus z is equal to 1. And because we are trying to determine the surface area, we only need double integral, not the triple integral. So first thing we need to do is find the area element. To find the area element, we need to parameterize the surface. So we can write z in terms of x and y. So using this equation, z is 1 minus x minus y. So x is x, y is y, z is 1 minus x minus y. So this completes the parameterization. Now let us do the cross product to find the area element. So because this only has x and y, first differentiate with respect to x, then differentiate with respect to y. If you differentiate with respect to x, derivative of x with respect to x is 1, y with respect to x is 0, 1 minus x minus y with respect to x is minus 1. Similarly, derivative of x with respect to y is 0, y is 1, this is minus 1. So I cap 0 minus minus 1 is positive 1, minus j cap minus 1 minus 0 plus k cap 1 minus 0. So this will give I cap plus j cap plus k cap. To find the area element, we need to further take the magnitude of this, which is 1 square plus 1 square plus 1 square, which is 1. So that's the area element. And we also need to write dy dx. I didn't write that one because 1 multiplied with anything will not change its value. Dy dx. So this is the area element. Now we need to determine the limits of integration for y. To determine the limits of integration for y, we need to freeze x. So if this goes away, if you only draw the triangle in the xy plane, if you project the original plane in the xy plane, we get this triangle. And because the equation of the plane was x plus y plus z is equal to 1, and because along this line z is equal to 0, along this plane z is equal to 0, if you substitute z is equal to 0 here, you get x plus y is equal to 1 or y is equal to 1 minus x. And this is the x-axis, so y is equal to 0, and this is the y-axis, so x is equal to 0. So at a particular x, it's going to be a plane like this. Y is varying from 0 to 1 minus x. So the limits of integration for y should be from 0 to 1 minus x. And to make it more clear, particular x is a plane like this, particular y is a plane like this. The point of intersection between those two planes is a line. Along this line, z has the equation 1 minus x minus y. So it's just a point. It's not varying from lower limit to the upper limit because it's a surface integral. So along this point, z is 1 minus x minus y. So it's a point here. As y varies from 0 to 1 minus x, z is a point here, 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 here. So it's tracing out a line like this. And as x varies from 0 to 1, these lines will trace out the triangle that we originally saw. They'll trace out this triangle. I do not remember the configuration. I think this was the configuration. So it'll trace out that triangle. So the limits of integration for x should be from 0 to 1. How I got this one is I solved y is equal to 0 and y is equal to 1 minus x, and I got x is equal to 1. So because along this line y is equal to 0. So the limits of integration for x are from 0 to 1 and y are from 0 to 1 minus x. So if you solve this integration, you'll have y 0 to 1 minus x. So if you substitute the upper limit, you have 1 minus x. If you integrate with respect to x, x minus x square over 2, 0 to 1. Oh, yeah. This one, I made a mistake. 1 square plus 1 square plus 1 square is not 1. It's square root of 3. So we also need to include square root of 3. You can write that outside because it's a constant. 1 minus 1 over 2, which is 1/2 square root of 3 or square root 3 over 2 is the area of that triangle. Thank you for watching. Bye.